And thanks for starting the recording. So now I will have another presentation. This is related to the string project. It's the project of swarms, UAV swarms based on energy-centric approach. This is the overall goal of the project, together with Tampere University by our colleague Sergey Andreev. I think I don't know if he's here today, but I think this is some of the one of the outcomes of the project, ongoing research, so that you can see that initial development. But I think this is very interesting to show how Jesse has been able to fly some UAVs with LoRa. And I think there is I know there is some interest for LoRa in Oulu, and also our colleagues from Brazil are here that are doing some research in LoRa, also in UAV. So I think this is going to be a nice way to show what you have been doing, what actually ES has been doing, and then maybe bring a new collaboration or new exchange of ideas to support the development and having like a better network, and like making new research connections and share some ideas. If not today, because of the time limitation, through emails, and maybe you can have a follow-up meeting later on. All right, so I think the floor is yours, Jesse, so you can start.
Thank you. Do you see my slide?
Yes.
Okay, good. So my name is Jesse Tolvanen. I'm a PhD student at LUT, and there's some unrelated stuff. I'm a specialty coffee nerd, and etc. etc. So the Pedro presented the project. So this is from our project website, and here you can see the project leaders. We have three groups, 2 at Lappeenranta and 1 in the Tampere. So why I'm doing this? So when I started my PhD studies, and the topic was drone swarms, I quickly realized that I think there's a problem with some existing swarm implementations, and especially in the communication side, because, well, usually the papers are presenting some kind of a drone swarm, and they are using either cellular modems like 3G or 4G, or nowadays 5G, or just basic Wi-Fi with some laptops. So yeah, the cellular connection is fine when there's coverage, but when there's no coverage, I think 5G has some solutions for that, but I'm not researching 5G, so I don't know much about that. Another interesting thing that has been proposed is IEEE 802.11s, which is Wi-Fi mesh. Well, it's also Wi-Fi. It has quite limited range, and I'm not sure what kind of hardware that does need. I'm not sure if the hardware is cheap or even easily available. And of course, there's another route which is using some proprietary protocols or licensed bands. Of course, military has their own spectrum allocations, and they can use as much power as they want. But if we want this to be like practically usable, we have to use the ISM bands. So yeah, so what would be the solution? IoT for the win. So the drones themselves are things, and we're not talking about Internet of Things, but there's some interesting similarities with drone swarms and IoT. So I have some prior experience with LoRa, so why not to use that? So that gives us some boundaries, some limitations. So we are not considering the communication requirements of payloads that drones can carry. So that means we are not going to transfer any live video or pictures or any high bandwidth streaming data. That's out of the scope of our research. And because of the limitations of LoRa and LoRaOne's data transmission capabilities, we're not going to fly in densely populated areas or airspaces where there's must be quite rigor requirements for reliability of the control link, and that's also for security. So if our research drones drops on someone Tesla, we don't want to pay that. So there has been quite some new development around this concept. So Italian researchers published interesting paper a few months ago where they presented an architecture where LoRa and LoRaWAN actually can be used as a communication medium with UAV swarm. And there are many papers that are considering LoRa gateways on drones to gather data from ground-based sensors. So the drones are flying gateways or data mules, however you want to call them. So you can get some idea about the performance that can be expected from the system like this. But the paper that's presented there, they didn't implement the swarm itself. They had some field tests, but they were not end-to-end tests. So about drones. So in the right, you see the military style drone. We are not considering those. They are outside of the scope of our studies, but we are considering those smaller drones, which are like few kilograms of weight, relatively cheap, and yeah, just much more easy to handle and acquire, so they don't cost so much. And what we are meaning as a UAV swarm. So as you might have seen, the Olympics had some light show with the drone swarm. So this is not that. We are more geared towards search and rescue or surveillance kinds of swarms. The swarm size in geographical terms is around 10-20 kilometers maximum. And the number of drones, we are estimating that, yeah, we will be under 100 drones, but that will be in our future tests, something around 5 to 10. That's more practical to use within our testing capabilities. And as you probably know something about LoRa, this is very quick recap. So it's a proprietary protocol. It's a physical protocol or modulation by Semtech, and its physical bitrate in European Union is 250 bytes per second to 11 kilobits per second. And its range can be realistically around 10 kilometers, or even better when there's line of sight. And LoRaOne is basically everything above that LoRa physical layer. So here you can see some diagram about the system. So LoRaOne defines all kinds of parameters, MAC layers, all the backend stuff for the traditionally IoT devices. So nice thing about LoRaOne is the MAC layer implementation is open. I think it was Ph.D license. So we can actually modify the MAC layer of LoRaOne and still able to use some commercial gateways. So we don't have to do everything by ourselves, hardware I mean. So we can develop things quite rapidly. But our system will look by modifying the LoRaOne MAC layer, we can actually allow the drones which are carrying LoRa modems to communicate via each other. So in regular LoRaOne, the node devices, so the like temperature or water sensors, they don't usually communicate with each other. They communicate only to the gateway. I know that there's some changes coming to that in future LoRaOne specifications, but we don't have that yet. But we can modify the MAC layer to allow that. So the drones can communicate via each other with LoRa or modified LoRaOne. And if we are using, or if we are modifying the MAC layer just enough, we can actually use the commercial LoRaOne gateways and even external gateways to get the communication going. And in the which is drawn as a blue boxes, you can see some of the hardware that's on the ground. So we have gateway, which could actually be also on one of the drones with like 4G or 5G backhaul. That will communicate with application server, and we can write any nice application, so we can integrate that to our ground control software. And also we can actually, I will have a picture for that. We can use some situational awareness mobile applications to control this swarm. So we are actually going to implement all this because it's nice to have some simulated data, but it's even more nice to have real data from real experiments and real systems. So this is a tiny little bit more detailed. So in the green, the drone. So in the drone, we have a PX4-based autopilot hardware, and that can be controlled with ROS, which is a robot operating system. And we can implement our drone swarming algorithms and whatnot in the ROS and control the drone by that. And because ROS is nicely modular, we can just hook up the LoRa or LoRaOne modem to that with UART and implement the interesting stuff with ROS. And also the LoRa modem with the gateway or with actually still controller drone at the beginning because, well, autonomous flight is difficult and a bit dangerous, so we have to have manual control for each drone to be safe and legal. Yeah, and our simulator architecture looks something like this. There's actually more stuff on the bottom, so we can actually try to use the thing stack, which is used in IoT applications, but that's actually very easy to do other service. Free situational awareness server, which integrates with CivTag, so it's an Android team awareness kit. So you can take any Android device and it will give you a map, and we will display all the drones in the map, and user can draw like mission area for the drone swarm, and the drones will get the information and update their swarming mission accordingly. So there's some things, and yeah, it takes some time to integrate all this, but it will be nice when it's finally working. So a little bit of recap from last slide. So we have services on the ground and some services or software on the UAV itself. The hardware we are actually using is this open source, or mostly open source, usually hobbyist grade DIY drones. So on the bottom left, you might be able to see on grass our like main research drone. So that has a flight time around 30 minutes, and that's our main workhorse. At the center top, you can see our tiny LoRa communications board. It has hardware for like regular LoRa and also 2.4 gigahertz LoRa on the same board. And because hardware is fun, on the bottom right you can see that yeah, the hardware revisions are never working at the first time, so requires always some tinkering. And as you might have noticed, there's a global chip shortage. So we designed this board first for one chip, and as you can see in the DigiKey screenshot, the availability date is in around 80 years or like, yeah, it's fun. But also flying is fun and regulations is fun. So as you might know, the EU regulations will come into force during the end of this year, and it will require to comply with the new regulations. And with these new regulations, there's different classes that you can fly, and there's open, specific, and certified categories. And the higher category you fly, the higher amount of bureaucracy you have to comply with. So we are trying to work within the open category, so we don't have to make all kinds of airspace reservations or UAV UAV like airspace allocations, but we are in progress of reserving those as well. So yeah, it's fun, and also working with a legal team is very fun. But actually, that is my presentation. I think there was not all the time used, but I think it's a good time for questions. Thank you.
Thanks, Jesse. Very good, very nice presentation. And I think it's very, very interesting. And well, one day you can tell everybody, as you told us in the other meeting, our struggle to get like a license to fly and so on. I think this is also very interesting. But I think now we have some time for questions. Very quick questions, because like you are on time. So one question is possible. There is one question here. There are two questions. So can you see in the chat? Yes.
Yeah, I can see.
So if you reply those two questions quickly, and then you can move on with Harun presentation.
Yeah, the first question is, could you justify what information is expected to be transmitted between the drones with n kilobits per second rate? The basic information is the drone's location, and probably we have discussions with Tampere team about more customized MAC layer. So there's well, we can have later discussions with that, but basically the location, and also if we are trying to do some kind of meshing, maybe some kind of routing tables. So we are actually experimenting with that. So we're not even sure what we have to do and what kinds of algorithms we can implement with this. So there was another question: what hardware will be used to run ROS on board a drone? So currently that drone will carry a NVIDIA Jetson Nano. It will be a bit heavy, but you can actually run ROS with Raspberry Pi, I think so, either one of those. And Alex asked, do you consider other regulations, USA, for example, or just in Europe? Well, I think USA has more bandwidth or more frequency allocations available for LoRa, I think. And in Europe, there was quite strict airtime or duty cycle limitations. So if we can transmit 1% of the time on air, and I think USA didn't have that, but they had like a dwell time limitation. So you can transmit for 400 milliseconds at the time, or that, as I understand, but we don't consider that yet, but yeah, it's good to keep in mind that the situation are different in each continent. Good question.
All right.
And for Harun 73.
Yeah, you can talk to each other then.
Yeah.
And now, thank you very